All right. So we're going to draw a picture of this. We've got a point 3, 4 on the terminal arm. Terminal arm of an angle in standard position. So first thing we have to do is decode some of the language here. It's an angle in standard position. Where does that start? It's going to start right here. Okay? The point 3, 4, x coordinate's 3, y coordinate is 4. That would be right here, 3, 4. The terminal arm of an angle is the place where the angle ends. So here is the point going through that. The angle is in standard position because it's starting from our x-axis. Maybe I'll draw that arrow. Just going to make this a little bit smaller. Woo! Do it right there. That angle is in standard position. We can figure a lot out about this picture. And we can figure a lot out about this picture using the math and the trigonometry we learned from previous years. But in order to use sine, cos, and tangent, what kind of triangle do we need? A right angle triangle. Can you see, even though that this keeps on going forever, that at this point here, if you dropped it straight down, you would make a right angle triangle. What do we know about this right angle triangle? How long is the bottom here, the base? 3. You know that because it goes through the point 3, 4. How tall is the triangle? 4. What kind of triangle is this? Right angle triangle. What is the hypotenuse? A squared plus b squared equals c squared. And it's 5. It's one of the special triangles. Whew. I want to get off topic and just talk about special triangles. Maybe we'll finish this question first. Then we can talk about, this is a special triangle because all the numbers are nice. 3, 4, and 5. And 3 squared plus 4 squared equals 5 squared. Okay. Now that we've drawn our picture, we have already solved A. What is the distance from the point to the origin? It's going to be 5. We need to figure out the primary trig ratios. Primary trig ratios are sine, cos, and tan. Next year you're going to learn the secondary trig ratios of cosecant, secant, and cotangent. But right now we're just doing sine, cos, and tan. And this is our angle right here, our angle theta. So looking at our diagram, what is sine of theta? What is cos of theta? And what is tan of theta? The answers are on our diagram. Sine is 4/5, because sine is the opposite side divided by the hypotenuse. And if our angle theta is there in the corner, the opposite side is 4, and the hypotenuse is always going to be 5. Then cosine will be 3/5. And tangent, 4/3. Then to figure out the angle theta, so part C, you could choose any one of those trig ratios to figure it out. Sine, cos, or tan. Pick one. Your favorite. Tan. Okay. So if you start with tan of theta equals 4/3 and you want to find the angle, you want to get theta by itself. So what do you have to do? You have to do the opposite of tan, which is tan inverse. So technically what we just did is we did tan inverse of both sides. Well, the tan inverse and the tan will cancel each other out because they are inverses or opposites of each other. And then we go to our calculator because 4/3 isn't one of the ones we have memorized. So you're going to have to think every time you see a fraction, is it one of the ones I have memorized for tan? And since it's not, we go to our calculator, we do tan inverse. And what angle is it? 53 degrees? 53 degrees when it's rounded? And there is our answer. Three, 4, 5, 8, 9, and 10. Well, I already assigned 3, 4, and 5, didn't I? Oh, maybe I haven't done 4. And 12. Those are all ones that you can do using SOHCAHTOA. Sine, cosine, tan, and making a triangle.